here we are in the propeller study. Now, for those of you who are new to the workbench, what we have here is a top-down approach where we firstly import our geometry. So on this little plus here, we can import the geometry. Now we can either come in from our direct link with Onshape. So if you're an Onshape user, then it's super simple. You just one click and you'll find your Onshape library, and then you can import any of your solid body models into the workbench. And also, if you do have other types of CAD file format, for example, .sat, Parasolid, .step, anything like that, we're going to be able to get into the platform absolutely no problem. Okay, so you upload that here, and then from your geometry, you're going to create your simulation. So using these the three dash button on the right here, we're going to create our simulation. Now, here's our extensive list of the different simulations that we can do here at SimScale. So starting from our finite element analysis, moving into the thermo analysis, and then coupling FEA with CFD, and then into our purely CFD. So we've got incompressible, we've got compressible, and some other new solvers which are really exciting, but sadly not for this webinar. And yeah, these are the fundamentals of what we do here. And the great thing is you can do one of all of these simulations on the same geometry in the same project and send them all off to the cloud at the same time, getting results back. Now, first thing that we need to do, once we have our geometry in, we've created our incompressible CFD simulation, we need to create a mesh. So the way we do this is just sticking to automatic settings. So we're going to use the automatic meshing algorithm, but we're going to apply some specific controls where we know we need specific refinement. So as I said earlier, we need refinement in the wake area of the propeller. So here I've created a geometry primitive which is defining the wake and the surrounding area of the propeller and the rotating zone. So as you can see here, here's the rotating zone, and if I hide that, we can then go in and see our propeller itself. So if we hide so here is our propeller, it is there, and this is our rotating zone, and then back onto our refinement areas. So here's our large wake, and then I've decided to do another smaller refinement region internally, so then we're having a nice smooth transition from coarse mesh to fine mesh, and then finally to very fine mesh on the propeller blades itself. So that's all controlled using these mesh refinements here after creating geometry primitives where you want to apply those mesh refinements. So to the actual external domain, I've applied this particular refinement, and then as we step down through the different regions, we can see that it's getting progressively finer. And then once we get into the rotating zone itself, it is getting pretty fine, and onto the propeller surfaces and then the propeller features as well. So it's always incrementally reducing or increasing the fineness. Now, if we actually have a look at the mesh, at the finished mesh, we can see that we've got pretty nicely refined rotating region. If we hide our rotating region, then we can see that the mesh on the propeller itself is getting pretty fine. Now then, enough about meshes, let's get into the exciting bit. Let's have a look at how we actually apply the physics to this simulation. So that's done using the boundary conditions that I went through earlier. So if we just show the whole mesh, we can see that we've now applied the boundary conditions to the mesh. So we've put slit walls on the side and the top and the bottom, and then we've applied the velocity inlet, and we've applied a pressure outlet. Now for this case, we're doing a free stream velocity of 4 meters per second with a RPM on the propeller of 6,000 RPM. And now that is going to give us an advanced coefficient of 0.19. Okay? And finally, or not finally, there's a couple more steps. It's not that quick. So we need to get our materials assigned. So firstly, let's put air on both the rotating region and the full mesh. Okay, so those are going to be the full air domain of the simulation. Simulation control, here's where we can utilize the benefits of SimScale. We can use a multiple number of processors to run this one job. Okay, and apart from that, I've used all default settings. Lastly, and most importantly, before I forget, we've got to actually say, we've got to induce the rotation of the propeller. So if we just hide a few of these surfaces again, and we hide our rotating zone, we are going to expect our propeller to be rotating in the positive y-axis. So the y-axis is going around here, and it's going to be rotating in the positive y direction. So that's using the right-hand rule. And then we simply apply our 600 or 6,000 RPM in rads per second. And then you are good to go.